Okay, let's look at the properties of log functions. Right. So first one's basic properties. Right. So if you have a log function of any base, if you plug in 1, what would you get? Right. Think about the power we need to raise b to get 1. So it's actually 0. So if you plug in 1 into a log function, you always get 0. Right. Or if you plug in the base into the log function, so log to the base b of b is going to be, right, power we need to raise b to obtain b would be 1. So it's going to be 1. Right? So those are basic properties, and you can always go back to the definition to find those values. You don't have to memorize them, but sometimes it's convenient to memorize them. Alright, next one is inverse properties. Since exponential function and the log functions are inverses of each other, so first one is apply, so you have x, apply exponential function, then apply log function. Right, log functions and the exponential function are canceling out, so you're just going to get x, right, because they are inverses of each other. Right, same deal. Only difference is this one, take x and apply log function first, then apply exponential function. But again, these guys cancel out each other, so you're gonna get x, right? So it's like canceling out. So we can probably do canceling log to the base b and exponential function, and cancel b and log function to get x. Alright, and the other useful properties, and the first one, log to the base b of x times y. If you have a multiplication inside the log, we can actually split it into 2 logs, so log to the base b of x and log to the base b of y, then turn it into an addition, right? So log to the base b of x times y is equivalent to log to the base b of x plus log to the base b of y. Right? Division works very similarly. You can see that the multiplication was addition, and you can kind of guess it's actually log to the base b of x minus log to the base b of y. Right? And if you have a power here, you can always put this power in front of the log. So you can write it as r times log to the base b of x. Right? And the last one is useful when it comes to solving equations. So if you have log to the base b of x is equal to log to the base b of y, if you have the same base, then what's inside must be the same. So then it means that x has to be equal to y, right? So those are the log properties that we can use, and these are very useful, especially when it comes to solving solving equations involving log functions. All right, that's it. I hope that this was clear.